now. Okay, welcome to this month's community call for Dapr on May the 18th. We have a super exciting packed agenda for you today. We've got a ton to go through. I'm going to spend a few moments just talking about the upcoming 1.2 release. We're then going to have Jeroen, Arta dive into some of the features you see inside here. We've just picked out a select few this time. Actually, the next community call, we're going to spend some more time on the 1.2 release as well, because there's one feature we didn't touch on today, which is about the console support, and we're going to spend the whole time on that on our next one. We then have people from the Open Service Mesh team who are going to show how Dapr and Open Service Mesh work together, which is going to be super exciting. We've shown Dapr with other service meshes, Linkerd and Istio in the past, and now we want to show how Dapr works beautifully with all service meshes. Aaron's going to spend a little time talk about Dapr talks, how we can spend, about a slide deck, how you can give Dapr presentations. We're going to look for some feedback on the VS Core extension and then have our standard Q&A. So let me dive in here a moment. We are pretty excited because we are about to cut a release candidate for the 1.2 release that will be out pretty much today or maybe tomorrow. And you'll be able to take advantage of that release candidate for the 1.2 release. The final release we intend to ship next week. So the release candidate gives you a chance to play around with this, find any issues, report them, get us some fixes inside here. We're sort of currently in code freeze for this. And just in terms of some of the highlights on this, of which the first three we're going to go through today, we're going to talk about how we've done support for Dapr security and the ACLs, some of the new components, supporting non-CloudEvent messages. As I mentioned, next week, we're going to spend pretty much the first half of it on how we've integrated console into name resolution. We're going to work with that with the contributor Man City group who helped build us this incredible feature. And then a couple of other things to worthy note is that the 1.2 release now has the ability to do preview features inside here. So you can actually turn on preview capability. And one thing that we've done for that at the moment is that we've introduced a feature for active reentrancy that enables you for actor A equals actor B and B calls back to C again. So A equals B and B calls back to A again. That reentrancy is allowed between actor instances are running. We just set that as a preview feature, just to allows you to sort of try that out. And I think this preview capability allows us to roll out features as we go along with our milestones, and allows us to kind of do sort of bug fixes and breaking changes within inside them as needed without having to sort of commit to the full code being GA ready at a particular milestone. So these are some of the highlights. You'll see a lot more come out, and of course in the release notes that we publish next week. And we are pretty excited that we continue on a great rhythm of releasing Dapr every 6 weeks with a lot of great community content inside here. So with that, I'm going to hand it over to Jeroen to dive into a couple of those features and to walk us through them. So I'm going to stop sharing, and I will hand it.
Thank you, Mark. I will share my screen. Let me know when it comes through.
Fantastic, we can see it.
Okay, hello everyone, and hello to the audience at home catching us on YouTube. This is gonna this talk is gonna be about Dapr ACLs for the Dapr APIs. So if you know, Dapr has this access lists feature for service-to-service invocation where Dapr allows you to put very specific access lists and prevent or allow certain applications to talk to other applications running in your cluster, whether it's on-prem or on a Kubernetes cluster. And it allows you to specify which APIs are available for which app and which methods and whether it's gRPC or HTTP or not. But what we've also heard was that if you're running Dapr in a production environment and you're using some of the building blocks, let's say your application is only using state or pub sub, you might not want to open up access to all of the other Dapr APIs. So we basically wanted to promote the principle of open what you use and don't open anything else. So for that purpose, we've introduced a section to Dapr configuration, and I'm going to show this running locally on my machine, but this is of course applicable to any environment the Dapr runs on. So in Kubernetes, you'd just be applying this configuration YAML here. And what's new in here is this API field here. So basically, what I have right here is I'm saying, hey, Dapr, only allow access to the state APIs for the HTTP protocol, and only allow access to version 1.0 of the state API. So let's take a look at what this looks like in practice. I'm going to use the Dapr CLI to just run the sidecar. So I'm not going to run an application next to my app. I'm just going to give it an app ID, just calling it node app, telling the Dapr CLI to tell Dapr to listen on port 3500. And I am referencing this configuration YAML file that I have here. So I'm going to kick this off, and this is up and running. Now I am going to go to Postman, and I am going to call into the local Dapr sidecar over localhost 3500. And I will call the state API, right? So I'm calling the state API, which is what we have listed here. And I'm calling the state store. This is the name of the state store. Dapr supports multiple ones. This is just the default one configured on my machine. And I'm just saving a very simple key value pair. Well, hello there. And so I'm just gonna fire this off, and we get 204, no content response. So the call went through. And if we try to get the value back, we can see that we get hello there, which is nice. Now let's try to send a message to a binding. So if I were to change this, and let me find the bindings call here. So if I was to change the API to bindings and try to target a state store binding, if you're in Dapr without the access list, you'd have basically gotten like access to the bindings building block, right? If you had a binding called state store, it would allow you to access it. If you didn't have a binding called state store, you'd get like a binding misconfigured exception error. But now if we do this, we're actually going to get a not found. And that's because the entire API and the entire building block in Dapr wasn't actually mounted here. So only the APIs that we allow in here are going to be specified. Now, if I wanted to, for example, allow the gRPC API, what I would do is use the gRPC versioning scheme, which is V1, because that's the versioning scheme we use for Proto. And we would have the gRPC protocol here. Same thing if I change the bindings building block now, and I'm going to stop Dapr and rerun it. And I'm going to go back to Postman and change this to state. And I'm going to try and save the state again. We can see that we get, oh, sorry, this is the wrong one. And call the state API, we get the not found, which is what we expect when we no longer enable it using the API. So this is it. There are docs about it. You can see that I'm using the V1-2 version of our docs. So the documentation you're seeing here are going to be available once we release version 1.2. That's going to come out this week or next week. But you have a few examples here for how to enable HTTP APIs, how to enable gRPC APIs, and then the names of basically all the APIs they are supporting that you can list from here, from the configuration. Okay, that's it. Back to you, Mark.
Okay, that's fantastic. I think what we continue to see is that we continue to add security up and down the stack with inside Dapr. And this is just another of the features. We have security across pub/sub, security across ACLs between components, and this is another of those security features. I think we're going to go back to you again, Jeroen, to talk about some of the new components inside Dapr. So in the 1.2 release, are you able to kind of talk through some of those?
Yes, but before I do that, I'm going to answer Lynn's question on the chat. So Lynn asked if this is applied at the namespace level regarding the configuration we've just seen. This is referencing a Dapr application. So this is actually as granular as a specific application, right? So you can choose which APIs are available to a given application and not just for a namespace or a cluster. So this is very granular, right? So you can decide that you open some APIs for one app that's using the state APIs, and then for a different API or for a different sidecar, which is, let's say, less trusted in our environment, we're going to block the secrets APIs, for example. So this is pretty granular. Okay, I'm going to share my screen again to talk about the new components. Let me know when you can see it.
We can see it.
Okay, so there are a few new components for Dapr. And this is again using the docs version for 1.2. And we're just going to go over a few bindings. So let's start with Alibaba Cloud Ding Talk. And by the way, kudos to Alibaba. They contributed a lot of bindings and also middleware in this release. So this is really good stuff. Alibaba Cloud Ding Talk is basically like the equivalent of Microsoft Teams. It's an online platform for collaboration where you can basically host talks and bots and basically just create a collaborative environment between groups and groups of users. So they enabled a binding that actually allows you to send messages into groups and perform all sorts of operations for the Ding Talk APIs. So if we go ahead and take a look at the binding itself, we can see that it's pretty simple. There's an ID of a webhook and a URL and a secret. And what you can do is basically receive events from a Ding Talk forum or message group, and you can also send messages to it. So there are a few examples here, for example, how to send a message into a group or how to get messages from a group, create them and get them. And I recommend just looking at these examples here, but this essentially enables you to communicate with the Ding Talk APIs over Dapr standard APIs and get all the benefits of Dapr bindings. The next thing that they enable support for is NACOs, which is a configuration management component that's offered as a managed service in Alibaba Cloud. That has a pretty extensive configuration here. NACOs is a pretty nice thing. It really allows you to deploy configuration objects, and I think I opened it here somewhere. There it is. It's an open source project. You can basically use it everywhere, not just on Alibaba Cloud, mainly used for configuration services where you can create new configurations for your application. You can put some access lists on them, and then basically just create groups of configurations for your apps and assign RBAC on them too. So this binding here has the endpoint and the access keys and the secrets for everything. It also allows you to watch changes to configuration groups, right? So for example, if you created a configuration group for your app and you want Dapr to invoke your app every time there is a change to a configuration, you can do that here with the watch, and Dapr will just call your app whenever a new configuration is added, removed, or changed. There's a bunch of metadata fields here. This is actually one of the more invested in rich bindings that we've seen. There is a lot of the underlying implementation of NACOs that's enabled here, and that's pretty nice. So you get like examples here. This is an example of how to get a configuration. So you specify the configuration ID and a group if you have one using the binding, and you can also create configuration groups. And this is a really well thought of binding that you can use in Alibaba Cloud, or you can just use it with the open source version of Apache NACOs. The third thing is RocketMQ, which is also run as a managed service in Alibaba Cloud, but the binding itself is just bindings to RocketMQ because it works with the open source version. So RocketMQ is a queuing system governed by the Apache Foundation. It's pretty popular. It has pretty low latency, and it's used a lot in data processing pipelines and orchestrations. It offers a bunch of features for users like ACLs, and this binding allows you to start sending data to it with all of the configuration that you can see here. So you can specify an instance ID for your RocketMQ, you can specify the topics, you can specify specific TCP configuration, and you, of course, have a pretty rich feature list for metadata items. So for example, you can configure the batch size that Dapr is gonna take into account before invoking your app. You can set the number of threads, for example, the server domain, and a bunch of other features that are exposed by RocketMQ. There's also some instructions here on how to set up RocketMQ in Ali Cloud, but again, you can use this with the open source version as well. And then we also have something called Zeeb. And Zeeb is basically like a stateful workflow serverless engine that allows you to send commands and create stateful workflows. It is also an open source project. You can find it at camunda-cloud/Zeeb. And this was contributed to us by Zeiss. So thank you a lot for that. It's basically a workflow engine for microservices. You can deploy it in Docker, but you don't have to. It runs in Kubernetes, but it runs locally too. It can consume messages from Kafka. And then once those messages are consumed by your app, you can set up pretty detailed workflows. It scales horizontally, so you can just add instances to the workflow engine. It's fault tolerant, and unlike other workflow engines, you don't actually need a relational database for it. And it comes with a nice bunch of features for monitoring and being able to analyze which transactions are really going through the workflow engine. So Dapr has now 2 types of new bindings for this. And those are called commands and job worker. So the command allows you to basically just send a command to the workflow itself. You can set up your root certificate here, set up the gateway address, pretty simple stuff. And then there's a bunch of APIs that are supported currently, right? So you can deploy workflows, you can view the topology of a workflow, you can activate jobs, you can complete jobs. This is really an awesome binding, and thanks again to the Zeiss contributors who did this. This really allows you to use Dapr bindings to talk to the most commonly used Zeeb bindings in a very language agnostic way. So like you don't need to generate any client SDKs, and if you want to use Zeeb from a language that doesn't support it, you can just do it with this Dapr binding. And there are very detailed examples here for how you do each and one of those things. So creating instances, and you have very specific schemas for the data structure that you need to do any one of those things. So I highly recommend checking out Zeeb and, of course, both the job worker and the command bindings. Okay, and this is it. So back to you, Mark.
Okay, fantastic. Let me share my screen here a moment. Those are some incredible examples of how the community will be adding those components, and we kind of welcome everyone those as they come along. And I think that as we see more of those, those integrations with some of those workflow engines are super important. We're seeing more of that. In fact, I think you'll see more generally with workflow as we get through, the next few months with Dapr, because we see a lot of workflow usage with inside Dapr. So I'm going to move on now to Arta. He's going to spend some time to talk about how we send and receive non-CloudEvent messages into Dapr. It turns out, of course, that we work very, very hard to make sure that Dapr is sort of agnostic and allows you to integrate with existing systems. And I think the whole point of what we're going to show today is with this capability we built into version 1.2 is how Dapr can be integrated into existing systems, so you can sort of migrate Dapr to be used in sort of existing application scenarios rather than having to transform a whole application. So let me hand it over to you, Arta, and you can start sharing your screen.
Mark, I think we need to make Arthur co-host.
Yes, let me do that. There we go.
Thank you very much. Let's speak. Okay. Okay, let me share my desktop. So the scenario here that we are addressing is when, let's say you are in a enterprise and not every application is using Dapr, and you want to make use of pub/sub capabilities through Dapr. Especially we have so many components implemented in pub/sub. But today you are forced to use CloudEvents, and CloudEvents has many advantages, and we're going to go through some of that today. But if the downstream service is not using that, or you're handling similar capabilities as CloudEvents at the application level, mimicking CloudEvent, you don't want to wrap those with CloudEvent and cause backwards incompatibility with the publisher or even other subscribers. So you want to just blend in with the existing infrastructure. So I'm going to have this app from to consume Kafka messages, and you're going to see how the events look like in Kafka, And you can think about this as a between quotes raw Kafka subscriber. A subscriber that doesn't understand cloud events, it just dumps what it sees. Okay, so I'm going to start this, and I'm going to wait for events. And now we're going to look at the pub sub example from the Java SDK. So here we have a regular publisher code, and in this publisher, we're just going to publish to message bus sample. And if I open message bus here, you're going to see it's just a Kafka pub sub. There's nothing different there. And then once you go to the publisher code, there's an optional new metadata called raw payload. You could delete this. We're going to put this just because it was copy and pasted from the other publisher. But this is an optional new metadata that you can set. And you're going to say to the publisher, publish the raw payload true or false. So if it says true, you're going to simply have the current behavior. Sorry, if it says true, you're going to take the payload as is and send it to the pub-sub component. If it says false, which is the default behavior, it's going to work as is, where you're going to wrap it as a cloud event and send it. If it's a cloud event, you're going to interpret this as a cloud event and send it as well. So if you don't want a cloud event, just say raw payload true. But in this case, let's just see the old behavior. Sorry, not the old behavior, the default behavior, because we want to keep that. I'm going to go through that why in a minute. So we're going to run this publisher. We're just going to publish 10 messages. Oh, did I send the wrong one? Let me see. Give me a second. No, I sent the wrong one. Let me send the publisher. Okay, publisher. Just publisher. Okay, send it 10 messages. And now if I go back, you can see that except for the first one that I used the wrong one, all of them are a cloud event, okay? And if I zoom in, you can see here, they all got wrapped as a cloud event. So if this publisher was like one subscriber, sorry, was one of the applications in your company that doesn't understand cloud event, you can say, oh, I cannot use pub-sub with Dapr. You could achieve some of it with binding as well, output binding, but not every pub-sub is available as an output binding. So this becomes a problem for partially adopting Dapr in a larger enterprise. So we're going to close this, and then we're going to do the same example, but with the raw payload, which the only difference, I'm going to zoom in here for you to see better, is the raw payload is true. We changed that. That's the only difference. So I'm going to send raw. And I'm going to see all those payloads here being sent, right? And then if you look here into our subscriber, okay, now they got the actual message without wrap as cloud events, okay? And then you think, oh, what about the other way around? What if I'm a subscriber and I have publishers that are not using Dapr, they don't want to wrap it as cloud events, and I just want to consume them as is. Can I do this in Dapr? And the answer is yes. And without a change in the SDK, actually, just in the runtime, I'm going to show how we do this in Java, but you could do this in other languages too. The only difference is when you subscribe, you have to pass in a metadata, right? That's an existing field that subscriber supports in Dapr. In this case, when I say raw payload true, okay, that's the only difference. And then if you do that, we're gonna run the subscriber here one more time. Wait, let me go to the right terminal. There you go. So we're gonna go to this subscriber here, and we're gonna see how it will receive the events. Oops, wrong screen. And then it's running. Okay, it got all the events, but it also got the cloud events that we sent before. But remember, because this does not understand cloud event natively, it just wrote the cloud event as is. So you would need to it understood the CloudEvent as the payload itself, without Dapr interpreting anything, which is something just because we did a demo. But ideally, if you have this scenario, you want to use CloudEvent. You don't want to use raw payload. And I will go through the advantages in a minute, like I promised. Last but not least, now that you have raw payload, you can also change and use binding, just to prove that it's not being interpreted as CloudEvents. So I can have an input binding here for Kafka, and I'm gonna get the same payloads that I showed to you. See, without the actual without needing a CloudEvent. But if you receive CloudEvent, just come count the data as is. It's not going to be interpreted. Just again, same thing. Now, what do you lose if you don't use CloudEvent in PubSub, and why it's recommended to use when possible? So if you look at here, one of these payloads, let me zoom in a little bit more. One thing you're going to see is trace ID. So you're going to lose tracing capabilities because Dapr runtime is not going to parse trace ID, and it's going to be able to tell you when the message was published and when the message was subscribed. So you might argue, yeah, but the publisher is not using Dapr to begin with, so that's already something I'm not using. So yeah, in those scenarios, make sense. The other thing that you lose is that the message has an identifier, and this is used for deduplication. This message identifier is generated by at the publishing side. So the message is published with a unique ID, and the message is delivered at least once. But the ID allows you to dedupe this on the subscriber side. If you don't have the message ID, you have no way to know if message 0 receiving twice is the same message delivered twice, or if it's a different message with the same content. You cannot differentiate that. So you need to handle this logic on the application side, not on Dapr. So another thing that's very important that you lose content type. So you don't know if the message being sent to you is JSON, if it's XML, if it's a picture, if it's a JPEG, you have no idea. So there has to be some sort of contract handled between the publisher and the subscriber up front, and no, I'm only sending this type of content to you. So CloudEvents exists for a reason. It solves common problems in PubSub. So it's highly recommended that you use PubSub with CloudEvents. And if you don't, just know that the cost of it, it's like making an HTTP call without any headers. You lose a lot of context. There's a reason why HTTP has headers, right? So you lose all of that metadata information if you don't use CloudEvents. That's the equivalent. That's the metaphor I like to compare for this problem. So yeah, so it's possible now to do it. Just make sure that you understand the costs, and that's it. So let me stop sharing. Do you have questions?
Yeah, let's see if we take a few questions on this. Fantastic. Anybody have any questions on that? Do you understand the reasons why for this? I mean, this is so that we can integrate with existing systems and take advantage of those. But once it's into Dapr, and you're talking between Dapr, certainly, as Arthur pointed out, CloudEvents provides many, many benefits.
Looks like there's a question in the chat.
Yeah, Lynn says, nice work. This is going to unlock many brownfield scenarios for existing integrations. Yes, that's exactly what it's there for. We just had people, talking to us and saying, how do we integrate with existing systems with PubSub? And so this allows us to do it now. It's important that we can't say that you have to use Dapr everywhere. We have to incrementally migrate, and this is another approach we've taken.
Donovan had also asked, what's the URL if you don't use the SDK to switch to raw events?
Okay, so you pass, so on the publisher or the subscriber side. If it's on the publisher side, you can get the metadata passed through as from my understanding is query params. So we can pass that through HTTP, just like you would pass any other metadata in the Dapr APIs. On the subscriber side is when you have the subscribe, and you pass the list of topics you subscribe to, you can say, oh, pass this metadata, and you can put some kind of key value pair inside the metadata like you would before.
Yeah, there, you can also register through a configuration file though. So in my YAML, what do I place in there? Because when I do pub sub, I don't change my code. I just register through a subscription YAML.
It will be in the metadata attribute. There should be a metadata there.
Okay, got it.
This CRD. If it's not, it's a bug because that's a pre-existing feature. We had metadata for this for a while. So it's just a new metadata.
Got it.
Okay, great question. Thank you.
Okay, let me share my screen here again. So thanks, Arta, talking us through that. We're now going to move on, and Shneha is up next. She's from the Open Service Mesh team, and she's going to talk to us about how they've done incredibly good work about how Dapr works with Open Service Mesh. In previous community calls, I'll post a link in this channel here. We've shown Dapr working with Linkerd. We've shown Dapr working with Istio. Dapr can, if you want it, is complemented by service meshes. And so we wanted to kind of bring in others into the fold. And so we thought today we'd also make sure we include Open Service Mesh and what's happening there. So I will hand it over to you.
Hey, thanks, Mark. Hi, everyone. So I'm Sneha. I work for the Open Service Mesh team. And I'm going to primarily show everyone. Can you let me know once you see my screen? Okay. So do you see the screen that says Open Service Mesh?
We do, yes.
Okay, perfect. So basically Open Service Mesh is a lightweight and extensible cloud native service mesh. We use Envoy as the sidecar, and we actually leverage service mesh interface, that's SMI, for configuring our envoys, be it for traffic access or traffic split. So that's the backbone for users to actually operate the service mesh. We have a whole bunch of docs that actually explains out to you on how to get started with Open Service Mesh and how to leverage this service mesh with all our features and basic demos to get started and work on these. We in this documents website, we've actually added a page here that talks to you in detail on how you can integrate Dapr with OSM. I've written out a detailed document on the steps that someone needs to follow at every level to actually run through and use OSM with Dapr. For the purpose of this demo, we are actually leveraging the Hello Kubernetes example that the Dapr team has laid out in their GitHub repository. So I will mainly be using this for the purpose of the demo. So to just get quickly started and with time, I've already installed Dapr on my cluster, Kubernetes cluster. So I can actually show you that it's running here. So I already have Dapr up and running on my cluster. So it's already running. And the other thing that I want to notify you is that Dapr actually so since we're going to be leveraging OSM as a service mesh, it's strongly recommended to actually install Dapr without MTLS. So that's what I have done in the process of installation. So I have actually disabled mutual TLS from Dapr's end. So this is the only customization that I've done in terms of Dapr is disabling MTLS. It's all listed out in the documentation there on the processes. And the other thing that I have done is I actually made sure that I installed the entire example for the Hello Kubernetes Dapr demo in actually the Dapr test namespace. The reason I did this is because we actually want to show you how you can add all the resources in this namespace to actually OSM's mesh. So because we've kept this in a dedicated namespace, we can leverage OSM to add this entire namespace. So going forward, whatever pods or resource you add to this namespace, they will become a part of OSM's mesh. So that's the reason why I did, I actually put this all in Dappr's in a custom namespace. Again, I have laid out the instructions and the steps that you need to take for making sure that these are up and running. So I have the Node app and the Python app up and running, and you can see both of these pods actually have only 2 containers as of now. So that is the application containers for each of them and the Dapr sidecar that's on them. And just to like show you that it all like works as is. So I'm just going to quickly tail the Node app to show you that the Python app can actually talk to this. This is prior to actually installation of open service mesh and actually adding Dapr to the mesh. So yeah, you see like the orders are still going as is. So it's running as is now. If we go back to the documentation, so this is all like I've created in a custom namespace, and then like it just talks about like because this is a custom namespace, there are tweaks that you have to make to Dappr's demo on like the role binding. So I've just listed out this out here for you as well. And I showed you that the applications are running as is with just Dapr. Now we have to come to the part where we install OSM. Again, for the purpose of this demo, I quickly installed OSM prior to this just to save some time. But we do have instructions in our manual demo guide, as well as like a bunch of other guides that will tell you how to install OSM on your cluster. Just for information purposes, the features that I'm showing you currently are on our main branch, and we haven't yet got a release for this. So it will be available shortly, but if you do want to try this out, make sure you actually enlist our repository and build OSM off the main branch, and then you can be able to leverage these features. So again, for the paper, so again, like I'll just show you that I have installed OSM on my cluster as well here. So yeah, so OSM is up and running on the cluster. So we have our OSM controller pod and our injector pods. I have done nothing special to actually install this. This is just standard out of the box. So if you follow the instructions in our website, you will be able to get OSM up and running. I will share links to these right after. So now if we go back to the documentation, so it says that, okay, OSM is installed, and now now we talk about some custom settings that you make in our mesh so that the integration with Dapr is smooth. So the first customization that you need is basically you need to make sure when OSM is installed, like when you basically configure OSM to have this permissive mode policy. What this means is basically service meshes and OSM in particular is a deny all by default. That is, so when you add your services to the mesh, they will not be able to talk to one another unless you apply policies, which I specified we do via SMI. And so we have this mode called permissive traffic policy mode, whereby you can basically skip the application of any SMI policy, and our controller will actually identify all the pods and services in the mesh and establish communication between them. So for the purpose of this demo, I'm going to simplify that. So then the next thing that we need to do is basically, so in the Dapr Hello Kubernetes demo, it's basically there is a Redis store, and the Node app accesses the Redis store using a Kubernetes secret. Hence now for OSM to because the Node app is going to be inside OSM's mesh, we have to make sure that this Node app has access to the Kubernetes API server. So for that, we will actually leverage OSM has this, again, we have another set of configuration in OSM that you can apply to be able to access the Kubernetes API server. So we have this outbound IP range exclusion, which basically, if you select, so you'll have to go in and look for what your API server IP address is, and you'll have to exclude this from your mesh. The reason is that the sidecar will no longer intercept. So OSM sidecar will no longer intercept this traffic, any outbound traffic from this IP address, and hence there will be continuous access to the API server. So the secrets will be, so the Dapr example can access the Kubernetes secrets. Then the other things that we need to, also take into consideration is that now the Node app and the Python app are like Dapr applications, and they will need to talk to Dapr's control plane. So again, we need to make sure that OSM sidecar actually does not intercept any outbound traffic from those. And instead of leveraging actually IP range exclusions, we're going to be leveraging another feature of OSM, which is the port exclusion list. So this is exactly identical to what I mentioned above. Like instead of supplying an IP address, you're going to actually supply a port. Now, if you like, again, Dapr has control plane has a whole bunch of services that are running. And so if you see, the primary ones that that will this particular demo will need access to is the Dapr API, the placement server, and the Senatry. And if you look at the ports of these, they're 80, 50,005, 8201, and again port 80. So we are going to leverage two of OSM's features to actually exclude these ports. So one is the one like I described for the IP address, which is just adding it to our mesh configuration. So if you notice here, like I'm just going to specify like port 50,000, 8002. And okay, so there's also this port 6379, which is actually the port to access Redis. So all of these I'm going to be are going to be excluding. And this is again, so when I'm excluding this, it's going to be done at a global level. That means going forward, any pod that joins OSM's mesh is going to exclude these ports from actually being intercepted by OSM sidecar. Now, if you notice, I have not added port 80 to this list. The reason is because port 80 is a common application port, and we do not want all pods that come into the mesh to be excluding this, because there can be some, a customer can run a combination of having pods that have Dapr plus, pods that don't have Dapr. So we don't want to exclude this out, and we want to actually give them the ability to do this at per pod or per service level. So then OSM has this other feature that is where we allow you to basically add annotations at a pod level. And that will, so this will allow, so we add port 80 there. Now I'm quickly going to actually go and like apply these that I discussed with you. So at first I'm going to go and so take our the IP range and actually exclude this from OSM. So if you see this patched, so it got applied to our OSM's configuration. That's called the mesh config. I'm going to quickly take the ports also and actually exclude these. So again, just the ports 50,005, 8201, and 6379. And now we can quickly look that this configuration has actually been applied. So we can look at our, so we have a resource called the mesh config, which is by default named as OSM mesh config in OSM system. So all of OSM's resources are in OSM system namespace. So if you look at this, you can quickly see that this IP range has been added and the ports have also been added. So now, so we are done with the configuration part of it. So also, like I mentioned, that I need to actually add the so we also add the port 80. So if you look at the Hello Kubernetes examples in Dapr's repo, what I have done is I actually made a small change here, and I added the annotation to actually exclude the port 80 for the Node app and for the Python app. So I've done these on those. So I will like, once I have the configuration set, I'm going to quickly redeploy these two. So that's done. Now I need to add the Dapr test namespace to our mesh, right? So OSM does provide you this facility with our CLI. So I'm quickly going to join the namespace, Dapr test namespace to the mesh. So I quickly add the namespace. So you see the namespace Dapr test is added to the mesh. Now I'm going to restart my deployments, the Node app and the and the Python app. So I have added those annotations for the port 80 on that as well. So I'll restart my Node app and let's restart the Python app. Okay, so restarted. Now let's quickly get the pods on the Dapr test namespace. So you see the pods have started running. So we have the Node app that has started running. And now at this point, it has 3 containers. And this explains that the third container is OSM sidecar that has been injected on that pod. Similarly, the Python app also is running with 3 containers. And again, so the Python app has also successfully joined OSM's mesh and has OSM's sidecar injected on it. So now I'll again like actually see if our Python app is able to actually make order requests to the Node app. And let's quickly make a kubectl let's tail the logs on the Node app. So we see again the order states are going on increasing. It's 23. So this shows that like Dapr has successfully joined. I mean, OSM has been added, and Dapr and OSM are running simultaneously on the mesh. Yeah, that's about it. I will. So so this is exactly what the document says, and we have been able to successfully. So now one quick thing I want to add here is that I mentioned that I actually ran this in permissive mode, wherein we didn't have to apply any SMI policies, but the document that I've written out here actually has steps on how to apply SMI policies. So it tells you how to disable the permissive mode. And then also I've given like detailed instructions on what like the traffic policies need to be, like the SMI traffic target. So it basically tells you that the Node app and the Python app need to be able to talk to one another. So I've listed out what the policies need to be and what the route groups, so which is like basically what the HTTP request will be. So I have specified that, so you can go ahead and try that and play around with the SMI policies and understand more of OSM's features. Yeah, that's about it. If anyone has any questions, I'm ready to take those now.
That's fantastic. Yes, I mean, showing how Open Service Mesh and Dapr work together and walkthrough has been super informative. Yes, thank you. That's amazing. Does anyone have any particular questions? Okay. I pointed to some docs. We put them all in the chat window in terms of the doc links there that we shared on OSM, the demo script, links to the Dapr docs about generally with Dapr running with service meshes. Go and check and read those out. Please give any feedback to the Open Service Mesh team. We really want to make sure that the Open Service Mesh and Dapr run well together. Open Service Mesh itself is being integrated as part of AKS, the Azure Kubernetes Service. And so you'll also see Dapr be able to work well with that. So if you using Azure and you're using AKS, that's one place that you'd be able to combine those two together. Thank you. All right, we just have a few moments left. I wanted to kind of use this time. We're a bit short on time. I wanted to just use it just for to give Jason a few moments just to ask if any about any requests on VS Code extension for feedback. So Jason, just take it away there a moment.
Yeah, of course. I'm just gonna link the extension on the chat, but I wanted to like just see where everyone was regarding like their experience with coding with Dapr using the extension, or if they had any particular interest in seeing any extension features in the future, even if they haven't like necessarily used it. I've gotten a lot of feedback regarding maybe like some fixes to the logging, certain features with the debugging, also including exposing a little bit more metadata. But I was just kind of like curious to see if anybody in the community had anything else or any particular pain points that they thought they wanted to share.
I know, where would you like them to reach out to you if you want to kind of put those comments inside the Discord channel?
Yeah, that would be great. If you guys can put whatever comments you have on the Discord channel.
Do we have an issue tracking this work?
Not necessarily, but there is a GitHub repository I can link where you guys can easily just write down some comments. Just give me a second, and I'll.
Your ask is you're going to post a question later on the Discord channel. There's a tooling thread inside there. There's a VS Code extension, GitHub repo. People ask questions in, and you just wanted to get people's feedback on what they would like to see in terms of features and capabilities and things like that. Yes.
Yeah.
Okay, because we've had some good comments in the past about the VS Code extension. We just want to looking for some more feedback around these things, and hopefully just kind of take it down the direction that you see as you'd like to see inside whether you want debugging experience, support for different languages, things like this. Is that right, Jason?
Yeah, that's totally right.
All right. Thank you. So post those links inside here in the chat window. I'd also put them in the code Discord channel straight after this as well. So we have about 5 minutes for any questions. Just to open up the community, we've packed a lot in this agenda. We won't pack it so much inside the next one. If there are any particular questions, we have a couple of minutes to answer those now. So feel free to post them in the window, or I can open you up and you can talk and ask those questions. So fire away if you have some. If not, while you're thinking of questions, I'm just going to go back and share my screen here a moment. One thing I wanted to kind of make sure, I also wanted to point out, is one thing that I posted recently is I posted this, are you using Dapr? So if you're going to look at this issue in the Dapr repo, 3169, we just had a lot of people ask us recently, can you just give some more examples of people who are using Dapr inside the community? And so we've published some case studies on our Dapr website, but we also wanted to reach out and ask you in the community whether there were other cases where we'd be using Dapr. So this issue, if you could go to this, if you can open up this issue, you'll see that it's this, I'll just open up in my browser here a moment. You'll see that it's in, this is the issue I've posted inside here in this repo. You'll see that also already we've had Xavier post inside here. We've had a few other companies post inside here, George Stevens from Solid Value Software. And so please, we would love to hear your details inside here so that we could just kind of reach out to you. Even if you don't mind, other people from the community can reach out to you and just talk to you about your experience with inside Dapr. So we'd love it if you are able to kind of post some of your details inside here, noting whether you're sort of in production or whether you're still inside development inside things. And then we were going to sort of take some of these and just put these inside our community repo where we have an adopted file inside here. And inside this adopted file, if you go look at that side, this is just a list of all those people who've posted inside here in terms of a link to their organization website and status inside here. So this just allows us to give a bit of view of the customer landscape of where we are, and would love you if you could contribute to this to see what you're doing. Okay, we have in the last few minutes, do we have any questions? If not, let's open up the chat window here a moment. I will stop sharing here a moment. I'll just return back to the chat window. Any questions before we leave? If not, thank you very much again for attending this, whether you're watching live or on YouTube. Next time, we are going to carry on a little bit about on View 1.2, and particularly we're going to spend a good 20 minutes, half an hour on the console integration for Dapr to be able to use name resolution so that you'll be able to use Dapr in particularly in sort of non-Kubernetes scenarios where you want to be able to do DNS resolution between two different services running, say, on different VMs, which is also sort of a targeted place where we see Dapr running. In fact, you can run Dapr in, and now with this console integration, just across a set of VMs where there's sort of physical machines, but particularly with this console integration, sort of a set of VMs, say, in a cloud provider to do that. So we'll spend a lot of time on that. You'll see the 1.2 release come out next week, and please try out the release candidate that you'll probably see released tomorrow or as our first release around that. So thank you very much for your time and have a great week.